Let's look at our givens and what we're trying to prove. We're trying to prove congruent triangles. And before we even start writing anything, let's make a plan. Okay? So we look at this and say AE and BD bisect each other. What does that mean, basically? Okay, I'm not going to write it down formally yet, but I'm going to think through it. Okay? So I'm kind of trying to model the process here that you should be doing. So AE and BD bisect each other. What does that mean? Bisect means to what? Just cross in the middle. Okay, they split each other in half, right? So do I get congruent parts from that? What are going to make congruent parts? AC and AE and CE, probably. Okay. So again, this is informal. We'll do it formal in a minute. AC and CE and BC and CD. And then, so what shortcut do you think I'm going for here now, do you think? Side angle side. Okay, so now I got a plan. Okay, I'm going to go side angle side. All right? Now I've kind of got a plan, and what we've kind of done is informally done the proof in our head. Now we're going to do it formally. Now we're going to write it out formally. So, and this is a good way to proceed. To kind of do it a little bit informally and then formalize it. So, step one, we write down our given, AE. Hold on, I want a thin line because a thick line for writing just doesn't look so good. AE and BD bisect each other. And the reason is given, yep. Now, anytime you're doing a proof, you always should get that first given, right? Okay, that's a point right there. You should never get a 0 on a proof because you should always be at least able to get the givens. Right? And what did that mean to us? What did we come up with as congruent parts? Remember, every given should lead us somehow to congruent parts. Oh, so what are we going to use then, since we use that word bisect, that keyword bisect? The definition of bisect, right? And what were the parts that were congruent because of that? AC was congruent to CE, and BC is congruent to CD, because they're bisecting each other. Great, awesome. And what was the other part we needed to get to side angle side? Angle ACB is congruent to angle what? DCE. And what do we call those angles again? So we say vertical angles. We could just say are congruent or vertical angles theorem, because that's a theorem, right? Or we can write vertical angles are congruent. Can't just write vertical angles. We have to have that are congruent or theorem afterwards. And marking that in, oh, that's everything. Triangle ABC congruent to triangle DEDC. And we know what shortcut we use, side angle side. That's pretty straightforward, isn't it? Okay? That's the process of proof. I mean, this is a thing that you've been stressing about for so long. But I think it's starting for some of you to say, oh, okay, I can do that. XY is parallel to WZ, XY is congruent to WZ, prove the triangles are congruent. Okay. Well, I know I've got XY congruent to WZ. That's a given. That's awesome. Okay, so I'm going to mark that in right away. Okay, so let's write that down. Because I love getting my freebies in right away. Okay, and sometimes when I do that, I even cross it off to make sure I know that I've used it. Okay, awesome. What else is jumping out at you? What are we probably going to use from this picture eventually? Again, we aren't formally writing it yet, but what are we probably going to use in this picture? XZ is a shared side, isn't it? We're going to have a reflexive property there at some point, probably, in this. And so I've got side and side. So once I got two sides, I start thinking, am I going to go for side angle side or side side side? because angle side angle is probably not going to be a big thing anymore or things like that. I got two sides already. But what do parallel lines give us? Parallel lines give us congruent angles, don't they? By what letter are we often looking for? Z. Okay, and what are my parallel lines? Now here's where we got to be a little careful. Which lines are parallel? X, Y, and WZ, right? These are my parallel lines. And there's my transversal. Where are my congruent angles going to be? And they're going to be the angles between the congruent sides, aren't they? So we're going to have what shortcut? Here. We're going to have side angle side again, aren't we? Sweet. Okay, let's do it for real. Okay? Let's do it for real. Okay. So, I used one given, my freebie. That's great. So now I'm going to use my second given. XY is parallel to WZ. That's also given. And what did the parallel lines give us? What do we get from the parallel lines? We get congruent. Parallel lines give us congruent angles. Okay, and what angles were those? WZX congruent to angle ZXY. Okay, now the Z, we can't just say because of Z. Okay, what did we call that angle pair when we had a Z? Very good. Interior angles theorem. And honestly, I'd probably be cool with it if you just said alt int angles. I'd probably be like, okay, good enough. You get the idea. Okay? You're not going to be super crazy about it. Fantastic. So now we mark that in. And what was the other thing we said we needed to do that we were probably going to use from the picture? The shared side. Oh, yeah. Because we're done with our givens, so you have to go to our picture, which is shared side. XZ is congruent to XZ, reflexive. And we said, yep, that's enough. We're going to have side angle side. Oh, I got to make sure I name it in corresponding order. Fortunately, we're given corresponding order right there, so I just copy it to avoid making mistakes. Boom. Okay? Are you starting to follow these things better? Are they starting to make a little more sense than they did last week? Okay? The more you practice them, the more I do it. That's why I've been doing kind of this double dip thing for the last few days now, because you see examples in the podcast, you see examples if you're watching a podcast, and you see examples on the board, and the more examples you see, the more you're going to say, oh, this time you did that before. Okay, now I see that again. A lot of repetition here. Okay? It's important that we get there because, like I say, today is mainly looking at more proof stuff. Yesterday was totally not proof. Today is much more proofy. Tomorrow we're actually going to go, what do we do after this? Once I know the triangles are congruent, what else can I conclude? And let's just think about that for a second. What do I know right now? I know three parts of those triangles are congruent, three pairs of corresponding parts. Are there pairs of corresponding parts I didn't know about? Well, yeah, because there's 6 pairs of corresponding parts in every triangle, right? 3 angles and 3 sides. Now that I know they're congruent, what do I know? I know all the rest of those parts are congruent too. So now I can start picking those out if I need them. That's the next step. Now that I know that, first I just had these 3 parts, okay? Now that I know this, I can pick out any other parts that I might need for something else. But we're still going to work through, get to congruent triangles first. It's still our first goal, congruent triangles. It's always going to be, okay? So that just kind of foreshadowed where we're heading for tomorrow. All right? So good stuff here, guys. And you are getting, honestly, I am seeing people like going, oh, I'm seeing light bulbs go on. I mean, you're not going to be perfect at it yet. But I'm seeing some light bulbs starting to go on, and that's really encouraging. Okay? If you can just, I mean, before you're like, I don't even know where to start. At least now you're going, oh, well, there's a shared side. Ding. That's good. Or like here, oh, there are vertical angles there. Ding. Okay, it's starting to happen. That's good. All right, let's get into groups. Let's get to work. I'll get this filed and uploaded to YouTube.